In a previous tutorial, we looked at preprocessor, how to build grid cell data, and we took data from digitized maps and put them into grid cell values, and then we did some work to make the grid cells inactive around the edge of the reservoir. In this particular tutorial, we will carry on with that data set and add additional parameters and show you how to infill the grid cell data even when you have no maps available to you. So let's open up the preprocessor, and in our previous tutorial we had saved a file called coutest1.dat, and if you open up that file and display modify grid cell values, it restores back to us what that file was, and we have put in from our maps net thickness, net top depth parameters. In this form, it is parameters with data. So we want to now show another parameter, for example, porosity as a parameter. And so this form shows us all the available parameters for parameter names and the shortcut 3-character keyword that helps us to identify quickly what parameter we're using. And if you want to click on the parameter names or the key header, we can sort the keywords in an easier or maybe easier to find. If you wanted to find, for example, porosity, porosity is down here, porosity, and then we're going to display this parameter, and once we have made some changes to it, it will show up with parameters with data on this side of the this box. So we're going to show this parameter for a given layer and for a given color. So when we say OK to display, this says that this is a new parameter and there's no values to set the legend range. So this is the legend range that we want to color the cells. So it's prompting us to enter minimum and maximum value in the following prompts. And let's say we're going to enter for porosity a range value, say from 0.05 minimum to a maximum value of say 0.3. Okay to that, and then it's going to draw for us now a contour map, a grid cell data map with a range of values from 0.5 to 0.3. And since we don't have any values, all be 0 initially. We click on all be 0 initially. So we can very quickly say all cells, a constant value. So all cells, the range, when you click on all cells, the range went from 1111 to the bottom of the reservoir, 3032. You can say a constant value of, say, 0.13, for example, and apply to range. It will populate all the cells at 0.13. Now, sometimes this is one way to infill to set the data if you believe it's all constant. But however, if we have some porosity values at the well points in our model, we could use some well log or core porosities to enter at the well points and then infill the reservoir based on those well points, drawing contour maps based on those well points. So let's try that. But in order to do that, we have to make those cells 0 values, because it's looking specifically for 0 value cells. So if you say back to O again, and we can set everything is 0, constant of 0, and apply to that, everything is 0. So now let's supply some values for, say, core porosities at some wells, and let's say in this cell, when I click on that cell, that is the cell I'm identifying, and say it's a constant value of, say, 0.16, for example. Apply to range, and that one is 0.16, somewhere around here. And let's say this is about 0.25, for example. That's all right, at 0.25, apply to range, and then click on that cell. It may be 0.18, for example. Apply to range, and this could be 0.0, 0.08 for example. Sorry, I hit too many points, but let me make this back to 0 again. 0. Okay, so I've got some porosities at the cells where the wells are, and I want to infill the model based on these 4 control points. So if I decide that I want to do the entire reservoir, I can arrange the cells to do the infill operation on. So for example, if I do the whole reservoir, you would set the range for me, and then I would go in and say edit, infill 0 value cells based on 4 available methods. Let's choose, for example, the inverse square distance method, and it says that it's going to infill the cells in the range selected, which is entire model. And the non-zero cells will be used for data, these non-zero cells. And so we say okay to that, and then it says what's the minimum cutoff value on the edges here. I'm going to say it's 0.05. It's our lowest value it's going to go down to. Say okay to that, and it infills. So this is exactly 0.05. So if I display rescale palette, this is 0.05. So just on the edge of 0.05. So this is one way to infill the reservoir based on well control points. In this reservoir, we only have 4 wells, but if you have 50, 80 wells, it's time consuming to click each point and get the cell value for the porosity or permeability. And there's another option inside Exodus preprocessor whereby you can enter a CSV file containing all the well points, and it will read that in and infill the reservoir for you based on a large number of wells. There'll be a different tutorial. So in this tutorial, if we carry on, if we didn't like some of the infill, and we said that we have additional information here that makes us believe that we got a better porosity, for example, in here, we could select a range of cells and apply a value of 0 to that, apply value 0 to the range of cells, and enter some fictitious value for porosity that we can re-infill. So let's say we put in point 2, for example, apply to range, and then we say I'm going to select the range of cells, and then I did infill from 0 cell values, and let's say we use just for demonstration purposes, a random number within the range, for example. And let's say we're going to go from 0.15 to a maximum value of 0.25 as example. Okay, and then it does a random infill based on a given value range. We also have normal distribution as the other infill method. This is just to give an idea of the infill methods available in Exodus preprocessor, and to get these values outside the well points. So another one that we can use is edit calculate by formula. So let's go and display, select parameter, and we see porosity is now added to this parameters with data list box. And let's choose available parameters, and let's choose permeability. Permeability, okay, to display and edit, and going to ask us if we have any values to use for the minimum and maximum to scale that palette. And we say we don't have anything, we just go back to basic 0, and then do we update? Yes, sure, we have updated previous values of porosity. And then so now let's go and calculate by formula the permeability from, say, the porosity using a cross plot formula of permeability versus porosity. So the formula can be applied to the entire range of cells, or just like before, we can select a range of cells here and apply different formula to different layers or different regions of reservoir. So this, for example, this show you to compute formula for this range of cells here. It's the edit, calculate by formula. So we have pre-selected the range of cells. When we click and drag this area here, and if we have made changes to our other data, we could save them, because if you reference those values, we want to reference the stored values of the parameters. It's a yes. And then in the infill formula, evaluate formula, we have this formula box when we have mathematical expressions here, like log, exponent, power, multiply, divide, with respect to grid cell parameters that we could use to compute the values from. So for example, the permeability can be computed as a function of porosity based on a formula. And just for example, I'm going to use this formula that I have in front of me here, 72.4 times the exponent of, in round brackets, exponent of, says 6.5 times a parameter, a grid cell parameter. For example, it is porosity. When it's a grid cell parameter porosity, we need to use a square bracket. So the code word reference one of these code words here, and the square bracket encloses a layer number. Staff is for the corresponding layers, so layer 1 to layer 1, layer 2 to layer 2, or a specific layer number. So let's use star, for example, and let's close it with corresponding square bracket, and close the final round bracket. So this is our formula, and we can say compute formula. And the exit is done, and this rescale palette, and we have computed our permeability for this range of cells using a formula. We could save the formula and to a file, and then come back and, if necessary, redo the formula if porosity changes, but we will not do that in this simple tutorial right now. So when we display select parameter, we now see that permeability is added to the parameters of data, and we can now go and save the data set, as this tutorial has reached a length of 12 minutes. And let's close and update the values and save that to access this data set, and let's go to save it for even though of errors, I'm going to save it in spite of errors, save it to COU test2.dat. Thank you for your attention.